On August 9, 2025, Harvard astrophysicist Avi Loeb published a short, unassuming blog post that contained one paragraph most people scrolled straight past. Buried in the middle of it was a claim that, if you actually stopped to read it carefully, was genuinely startling. The trajectory of 3I Atlas, the interstellar object barreling through our solar system, wasn't just passing near Mars by chance. According to Loeb's own calculations, the timing of its path put it on a collision course, not with a planet, but with a statistical anomaly so unlikely that he assigned it a probability of roughly 1 in 200,000. His conclusion wasn't gentle. He suggested in plain language that the arrangement of this object's path past Venus, Mars, and Jupiter was so improbable that it might not have been an accident at all. It might have been designed. This is the real story of that claim, the serious scientific fight it triggered, and the very human, very bureaucratic reason the world nearly missed getting a clear look at the truth. Let's start with exactly what Loeb actually said, because the real version is more careful and more interesting than any invented headline could manage. Loeb pointed to a specific, quantifiable feature of 3I Atlas's motion. It travels on a retrograde path, meaning it moves in the opposite direction to the planets orbiting our sun, and yet its orbital plane sits within about 5 degrees of the ecliptic, the flat disk in which all the planets circle the sun. Loeb calculated that a random interstellar object, arriving from any direction in the galaxy, would have only about a 2% chance of aligning that closely with the ecliptic, while also moving backward relative to the planets. Then he went further. He noted that the timing of the object's arrival brought it into close range of Venus, Mars, and Jupiter in sequence, all within a period of several months. A coincidence? He calculated at odds of roughly 5%, or about 1 in 200,000. Combine those two figures, Loeb argued, and you're looking at a trajectory so carefully threaded through the solar system's major bodies that it starts to resemble something engineered rather than random. He even floated a specific, if speculative, mechanism for what that might mean. A spacecraft passing through the inner solar system on a retrograde path, close to several planets but carefully staying tens of millions of kilometers from Earth, could in principle be releasing smaller probes timed to reach those planets as it swept past, using its own motion as a kind of cosmic drop-off. That's a real, quantified, published claim. It was picked up widely, reported without much scrutiny by dozens of outlets, and inevitably grew a life of its own online, evolving from a specific published probability calculation into a much broader, vaguer idea that Mars itself had somehow been targeted. But here's the part almost no viral video bothers to include. This claim did not go unanswered by the scientific community. It triggered one of the more substantive technical pushbacks 3I Atlas produced during its entire passage through the solar system. The most direct rebuttal came from a data scientist named Jorge Abreu Vicente, who laid out the problem in plain terms using an analogy anyone can follow. Imagine shuffling a deck of cards and dealing yourself a specific hand: the 7 of hearts, the Queen of diamonds, the 3 of clubs, the Jack of spades, and the 2 of hearts. The odds of getting exactly that hand are roughly 1 in 2.5 million. But does that mean the deck was rigged? Of course not. Some hand had to come up, and whichever one did would have been just as astronomically unlikely in isolation. Abreu Vicente argued that Loeb's calculation made exactly this mistake, a well-known statistical trap called the post hoc fallacy, where you calculate the probability of a specific outcome only after you've already observed it, rather than asking the more meaningful question up front. The real question isn't, what are the odds of this exact configuration of planetary close approaches happening? It's, what are the odds that any interstellar object passing through the solar system would end up close to at least a few planets, at some point, in some order? To actually test this, Abreu Vicente ran a Monte Carlo simulation, a computational technique that reruns a scenario thousands of times with slightly different starting conditions to see how often a given outcome occurs by pure chance. He varied 3I Atlas's arrival time across 10,000 randomized trials, while holding its actual orbital parameters fixed, specifically to test how often an object on a similar path would end up passing within tens of millions of kilometers of 3 or more planets purely as a matter of geometry and timing, without any planning required at all. Separately, Penn State astrophysicist Jason Wright, who studies the search for extraterrestrial technology as part of his own academic work, published a detailed methodical rebuttal directly addressing Loeb's broader list of anomalies, this specific trajectory argument included. Wright pointed to a mathematician named Hector Socas Navarro, whose independent critique of Loeb's statistical reasoning reached a similar conclusion. Computing the probability of one specific observed orbital feature after the fact is not the same as demonstrating that the feature is actually anomalous. Wright also raised a second related issue. Survey telescopes designed to search for hazardous asteroids and comets, including the very Atlas survey that discovered this object, are naturally more likely to detect objects passing near the ecliptic plane, simply because that's where the survey's cameras spend most of their observing time, scanning for anything that might threaten Earth. That means any interstellar object we're likely to actually catch and confirm in the first place is already statistically more likely to be found close to that plane, regardless of whether its true path was designed or entirely random. In other words, the very method we use to spot these objects quietly stacks the deck toward exactly the kind of alignment Loeb flagged as suspicious. It's worth being fair to both sides here, because that's what actually happened, rather than a clean, one-sided debunking. Loeb himself, in a separate and more reflective piece published in December 2025, acknowledged the difficulty of drawing firm conclusions from a single trajectory, explicitly noting that the object's path could just as easily have been aligned with any number of other reference planes, or pointed back toward any number of other notable directions in the sky, and that any of those alternate configurations would have seemed equally interesting had they occurred instead. That's a meaningfully more cautious framing than the approach to Mars was planned, and it shows Loeb engaging seriously with the statistical objections raised against him, rather than simply dismissing them. He continued to maintain that the configuration was worth flagging and studying, while being explicit that he placed the overall probability of a technological origin for the object at somewhere around 30 to 40%, a genuinely uncertain hedged position, not the confident declaration of hiding something unbelievable that spreads in clickbait titles. It's worth understanding that this trajectory argument didn't exist in isolation. Loeb had been compiling and refining an entire running list of what he called anomalies throughout the second half of 2025, eventually organizing them by their calculated statistical likelihood, from the most improbable down to features he acknowledged could plausibly be ordinary statistical noise. The Mars-Venus-Jupiter alignment sat near the top of that list, at odds of roughly 1 in 200,000, but it wasn't the only eyebrow-raising figure. Loeb also calculated that the direction from which 3I Atlas arrived coincided, to within about 9 degrees, with the direction of the famous 1977 WOW signal, a brief, unexplained radio burst detected decades ago that has never been definitively explained and has long occupied a strange, half-serious place in the search for extraterrestrial intelligence. Loeb assigned that coincidence a probability of about 6%, placing it by his own ranking in a middle tier of anomalies he considered could be a statistical fluke, a notably more cautious label than the one he applied to the trajectory alignment itself. He also flagged the object's extreme negative polarization, a measurement of how sunlight scatters off the dust surrounding the nucleus, as statistically unprecedented among every comet ever measured, including Borisov, the second interstellar object detected back in 2019. Each of these figures, taken individually, sounds dramatic. Taken together, arranged carefully by likelihood and paired with Loeb's own explicit hedging about which ones might just be noise, they form something closer to a genuinely rigorous, if controversial, research program than a simple declaration that aliens have arrived. That's an important distinction the viral version of this story consistently erases. Loeb wasn't claiming certainty. He was assigning probabilities, revising them as new data came in, and inviting other scientists to check his math, which is exactly what happened, repeatedly, over the following months. The rebuttals themselves are worth walking through in a bit more detail, because the reasoning behind them is genuinely illuminating, not just a dismissive wave of the hand. Wright's central point, articulated in one of his own memorable phrases, was that comets behave like cats. They have tails, and they do more or less whatever they want, meaning that no two comets, even ones formed inside our own solar system under broadly similar conditions, ever look or behave identically. From that baseline, he argued, an object formed around an entirely different star, under conditions we've never directly sampled, would be expected to look strange to us almost by definition, without requiring any exotic explanation at all. On the specific trajectory claim, Wright's citation of Socas Navarro's critique made a point worth repeating in plainer terms. If you only calculate the odds of a pattern after you've already spotted it, you can make almost any real-world coincidence sound impossibly rare, because you're implicitly comparing the observed outcome only to itself, rather than to the full range of equally unremarkable outcomes that could have happened instead. Abreu Vicente's Monte Carlo simulation put actual numbers behind that abstract objection. Running 10,000 randomized trials, varying only the timing of the object's arrival while holding its real orbital geometry fixed, allowed him to directly measure how often an object on a broadly similar path would end up passing within tens of millions of kilometers of 3 or more planets, purely as an accident of timing and geometry with zero design involved. The result of that simulation directly informed his conclusion that Loeb's originally cited probability, while mathematically correct for the single, specific configuration actually observed, dramatically understated how often some close approach to some combination of planets should be expected to occur for any interstellar object passing through the inner solar system on a similar type of path. In plain terms, it's not that the exact hand of cards Loeb described was likely, it's that some equally rare-looking hand was always going to be dealt, and act surprised. On October 3rd, 2025, 3I Atlas made its closest approach to Mars, passing at a distance of roughly 29 million kilometers. In anticipation of this rare event, NASA had positioned multiple assets to observe it. The high-resolution imaging science experiment camera, known as HiRISE, aboard the Mars Reconnaissance Orbiter, was set to capture images offering roughly 3 times the spatial resolution of the sharpest picture taken up to that point, a July 21st Hubble image. There's also a broader, more sobering point buried in NASA's own public statements during that November briefing, one that rarely makes it into either the sensational or the purely reassuring versions of this story. Officials from NASA's Planetary Defense Coordination Office noted that they were able to determine right away that 3I Atlas posed no danger to Earth, emphasizing that even at its closest recorded approach to the Sun in late October, the object remained at least twice as far from Earth as the distance between Earth and the Sun itself. But they also used the moment to highlight something else. 3I Atlas represented a genuine, real-world test case for how well humanity's planetary defense infrastructure can track and characterize an unexpected object entering the solar system with essentially no advance warning. NASA's acting planetary defense officer noted that as more advanced ground-based survey capabilities come online in the coming years, including a dedicated near-Earth object surveyor mission still in development, astronomers expect to detect a steadily increasing number of interstellar visitors like this one. In other words, 3I Atlas wasn't just a scientific curiosity or a source of internet speculation. It was also, quietly, a genuine dress rehearsal for exactly the kind of detection and tracking challenge that matters for actual planetary safety, regardless of how contested the more speculative anomaly claims about it turned out to be. So where does the real, complete version of this story actually land? Avi Loeb made a specific, quantified, and genuinely serious argument that 3I Atlas's path past Venus, Mars, and Jupiter was too improbable to be pure chance, and floated the possibility that the trajectory had been deliberately designed. That claim was met with equally serious, equally quantified pushback from other scientists, using a well-established statistical principle and an actual computational simulation to demonstrate that the same kind of surprising alignment is exactly what you'd expect to see some of the time purely by chance, once you account for how these objects are actually discovered in the first place. Separately, and for entirely unrelated bureaucratic reasons, the real images from Mars orbiters were delayed for more than a month by a government shutdown, a delay that fueled genuine public suspicion and frustration, including from Loeb himself, but which resolved, once the shutdown ended, into a fairly unremarkable set of images showing exactly the kind of coma and outgassing behavior expected from an ancient natural comet. Neither half of this story needed to be exaggerated to be worth your attention. A real, published, hotly contested statistical argument between credentialed scientists about whether a once-in-a-lifetime visitor's path through the solar system was too neat to be coincidence. A real, month-long bureaucratic delay that turned an ordinary funding lapse into a genuine flashpoint of public distrust. And a real, if slightly anticlimactic, resolution once the actual data finally reached the public. That's a far richer, far more honest story than a headline promising the approach was secretly planned and that what it's hiding is unbelievable. The real version doesn't need an invented twist, because the actual scientific disagreement and the actual month of silence that followed it were dramatic enough entirely on their own. If there's a single lesson worth taking from this particular chapter of the 3I Atlas story, it might be this. The most convincing sounding number in the world, a probability calculated down to a fraction of a percent, can still be built on a subtle statistical mistake, And the most suspicious-looking silence from a government agency can still turn out to be nothing more sinister than a funding fight in Washington, running into an unlucky comet flyby. Both of those things are true here at the same time, and untangling them honestly is far more interesting than collapsing the whole story into either it was definitely planned or there was definitely nothing to see. The real answer, as it so often is with genuinely unresolved science, sits somewhere in the more careful, more contested, more human middle. It's also worth remembering just how quickly this entire sequence of events unfolded, and how many independent people had to weigh in, correctly and skeptically, for the fuller picture to actually emerge. Loeb published his original trajectory claim in early August 2025. Abreu Vicente's statistical rebuttal, complete with an actual Monte Carlo simulation rather than just an assertion, appeared by late December of that same year. Wright's broader rebuttal, citing Socas Navarro's independent mathematical critique, came out in between in early November. None of these people were working for a single, coordinated debunking effort. They were independent researchers in different institutions, arriving separately at similar conclusions using different methods, which is itself a meaningful form of scientific confirmation. Meanwhile, the actual Mars flyby images sat frozen behind a government shutdown for the entire month of October and into mid-November, meaning the loudest, most viral phase of the something is being hidden speculation played out during exactly the window when no actual data was publicly available at all, a near-perfect storm for rumor to fill the silence left by bureaucracy. Once that silence finally broke and the actual pictures came out, the resolution was almost deliberately unglamorous. A fuzzy white ball of gas and dust, exactly the kind of image a coma-shedding comet ought to produce, described in exactly those plain, unremarkable terms by the scientists who'd spent months anticipating it. That gap between the drama of the speculation and the mundanity of the actual result is itself worth sitting with. It's not a story about aliens being covered up. It's a story about how easily a real, quantifiable, genuinely debated scientific claim, combined with an unrelated but perfectly timed bureaucratic delay, can snowball into something that looks, from a distance, exactly like a conspiracy. Even when every person involved, from the scientist most associated with the alien hypothesis to the NASA officials releasing the images, was operating in good faith the entire time.